Okay, morning, afternoon, everyone. I'm Liu Pan. Now I'm a research master in National University of Singapore. Honored to share my thought, which focus on data sharing game of autonomous driving in mixed traffic scenarios, combining game theory and multi-agent reinforcement learning. Okay, first of all, I'll introduce some important hypotheses based on the existing research. The first figure shows the early development may temporarily reduce traffic efficiency and safety. The second shows that as the number of participants increase and the average cost for data privacy protection goes down because of the scale law. And the final shows that as the level of the cooperation increase, the cost of technology and development decrease. Autonomous driving technology development face the following issue: poor initial results, high investment and costs, trade-off between the data protection and utility. Though there are some effective solutions like government subsidies, federal learning, differential privacy, and multi-party secure computing, the challenges still exist. How to develop so my question is how to develop a subsidy strategy, cooperation strategy, and operation strategy. So the problem I'm really interested in is how to form a cooperation model and get optimal strategies for everyone. The background focus on Asia, and there are huge market size. East Asia will represent 13% of a 400 billion autonomous driving market by 2035. Drone logistics market is booming. Quarter and annual growth in Southeast Asia, and advanced technologies are widely used to improve efficiency. The next key factor is the government layouts. China's MIT strategy, Singapore's smart mobility 2013, and Japan's Society 5.0 all shows a strong government commitment. And in short term, the CV penetration rate gradually increases, and the mixed traffic system is more complex, as shown in the right figure. AI is widely used today, and data-driven methods, including end-to-end, a visual large language model, require massive amount of data. And data safety and privacy are essential, especially in traffic area, because a data leak may cause serious accident. With this background, our version includes governments promote autonomous driving technology and infrastructure via policy and regional cooperation. And enterprises accelerate research and development with financial and policy support. And user benefit from safer and more comfortable travel. Next is our multi-level cooperative multi-agent reinforcement learning framework. A three-level cooperation model as shown in the right figure, and level 1 is between the government and enterprise. The government offer subsidies to each enterprise to incentivize autonomous driving development. And level 2 is enterprise cooperative games. Enterprises cooperate through the multi-agent reinforcement learning to develop shared strategies. And level 3 is between the enterprise and the users. Enterprises set the operational strategy that incentivize users to share their data in exchange for enhanced service. User behavior is reflected through the traffic conditions, and the government adjusts the subsidies to enterprises based on the operating conditions of the traffic system. This framework ensures mutual benefits for all parties. The model next is let's move to the multi-level cooperation models, input, output, and key goals. The input, including the three key factors. The first one is traffic operating conditions. the most is a CV penetration rate and also technology maturity and the preference of government and enterprise is also the input. And we can get 3 strategies: the subsidy strategies for the government, and the cooperation strategies and operation strategies for the enterprises to optimize data sharing. The key goal here is sustainability, both in terms of economics and technology advancement and the environmental friendliness. A number of indicators to assess the stability of the cooperation as shown in the right table. Through this model, we aim to achieve long-term cooperative stability. However, the potential risk cannot be ignored, including reward hiking. Some enterprise might game the subsidy structure to maximize the funds without truly contributing to cooperation. And the next is monopoly risk. Large players might form monopolies and push out the smaller enterprises. And cybersecurity is also a key point. Shared data could be exploited for unsafe purpose. To mitigate this risk, we list a few strategies, including the regulator in the loop, adaptive caps on subsidies to prevent abuse, and tiered data sharing. Only anonymized metrics are shared to maintain the privacy. And the red team audits regular white hat tests to identify any strategy exploration. And sunset clause freezing the development if any monopoly concentration or unsafe behavior exceed a value. These mitigations ensure our system remains safe and competitive. Specific enhancements still need to be verified experimentally. And there is a 3-phase roadmap. Phase 1 focuses on the experimental scenario construction, including validation and calibration. And phase 2 focuses on the algorithm design and optimization. And phase 3 focuses on the comparison and robustness test in different scenarios to observe the changes in the evaluation metrics and verify the adaptive of the framework in new scenarios. After initial exploration, host a workshop with regulators and enterprises is an effective way to apply it to reality. And successful validated models and frameworks can be extended to the development and diffusion of emerging technologies across the regions, including like grid energy distribution, regional healthcare resource allocation, and also AI technology development. And so, in closing, I believe that cooperative AI will make the world safer, more efficient, and more comfortable. Let's fight for it. That's all. Thank you.